Let's talk about RAG. Retrieval-Augmented Generation is an AI framework that improves the accuracy and relevancy of large language models by allowing them to retrieve context from external sources like documents or corporate databases before they generate a response. RAG became popular within the late 2022 and early 2023 after the release of ChatGPT because it was able to give us a solution for the inherent problems of LLMs, which was hallucination, inability to stay up to date with latest information, and ability to extract data from smaller domains like a company database, for instance. RAG is so important because they act as a cost-effective alternative to fine-tuning models. To fine-tune a model, you would usually take an already existing model, a pre-trained model, and train it further on smaller scoped data sets so that they can perform better on specific tasks or domains. Updating a fine-tuned model's knowledge bank is usually more time-consuming, more complex, and takes more effort. While RAG offers a simple approach by just updating the documents in which the knowledge bank was built on. So how does RAG work? Let's use this image to explain further. A user gives a query. The retrieval mechanism uses semantic search in the vector database by converting the user query to embeddings and using vector cosine similarity. So the embeddings are just like a vector that contains a long list of numbers that explain the features of the words that we have in database or in the document. Right? So the query as well is also converted to an embedding, and the retrieval mechanism uses cosine similarity or like dot product to check how similar each record is in the store to the query. This way, it fetches all of the relevant documents and sends them to the LLM. LLM takes in the query and the retrieved documents as context to generate a response to return to the user. I'll leave a link to resources to learn more about this concept in the description below. Today, I will show you how to build a RAG AI agent that tells stories about Southern Nigerian folklore using Mastra and Qdrant. To do this, we use this book called Folk Stories from Southern Nigerian West Africa by Effin Stone Daryl. I remember reading some folk stories from this book when I was a kid, but I don't really remember everything. It's very faint. So hopefully the AI agent can remind me of some of the stories and I can ask it some questions to elaborate more on some ideas. All right, let's dive into the code and get started. All right, first things first, go into your working directory and we'll create Mastra. pm create Mastra. This should ask you what you want to name your project. You can name it anything. I'm going to name mine RAG agents preview. You can go ahead and choose all of the defaults. I'm just going to go ahead with OpenAI, but you can choose Anthropic, Grok, or any of them. I already have credits in OpenAI. Also, you need to create, for any of these providers you choose, make sure you have an account with them and you have credits and you have their API keys because we're going to need them in the project. So if you're choosing OpenAI, go to openai.com and create your account and then get your API key. You can put in your API key here, which generates an env variable with the variable for OpenAI key in there by default, but I'm just going to skip that. You can configure master tooling for any agents. Sure, no problem. I'm going to use Cursor and Codex. This basically tells your coding agents, gives them instructions on how to solve certain problems. And you can initialize a new Git repository. So we'll just wait for that to install and then we'll get back when it's done. All right, that's done. Next thing to do is to change your working directory into the project we just created. And then we'll open Cursor in here. Yeah, Cursor is open. Next, we want to install our dependencies. So in this project, we're going to use Mastra RAG, Qdrant, and the AI SDK. So we're going to first of all install those dependencies, pm add at Mastra rag at Mastra Qdrant and AI. So that should install. Okay, as I said earlier, we're going to make use of Qdrant. So we need to get our Qdrant URL and Qdrant key. To do that, we'll navigate, we go to Chrome, and then we navigate to qdrant.tech. You can choose to log in or create an account. You're only allowed one free cluster, which is more than enough for us. Qdrant is pretty good because it's optimized for vector search and creating RAG databases as well. So you can log in, create a new cluster. There will be some onboarding tips. I can't go to the onboarding tips anymore because I already created my own cluster. As you can see, this is using the free tier. So follow the same steps and you'll be able to get your free tier cluster on Qdrant. Make sure you get in your URL and your Qdrant key. It's very important you copy them once they're shown, because if you close out the modal, you won't be able to get the access to the key again. So take that out, take the key and the URL when you have access to them, and put it in an environmental variable. Okay, next thing is we're going to create a file called rag, or folder called rag, and then we'll create a file called index.ts. Then we will want to go on ahead to grab our document, right, for the Southern Nigerian folklore book. So I'll create a public file in Mastra directory. Then I'll go on to copy, download the folk stories from here. You can download it as plain text. You can download it as HTML. With Mastra, you can parse in HTML or text or Markdown. But since plain text is available, just install it from here. It's free. This is a free website. It's an open repository for all of these kind of books. So just click on that and click on Ctrl S to install it or save it into your document or your local directory. So I already did that. I'm going to just copy it into this directory now. Okay, I was able to get in the folk stories in here. So this is the txt file of the entire book in my repository. You can also, once you'll get a link to this project in the description, so you can get the book on there as well. So in this rag folder, we're going to instantiate our vector DB. So to do that, I'm just going to copy in this code that I already did before in here. So basically what this does is that we're trying to resolve a path to this book in our repository, and then we are going to read the contents of the path, and then we pass that as a string into this M document. So this M document comes from Mastra, which allows us to process the documents in many ways. So we can either process it as Markdown, as I said, or HTML format. But since we're using the text file, we can just get the contents and put it in here. Next, we're going to divide the documents into chunks because we don't want to put the entire file into the database. It's going to be difficult for the agent to segment and know what is relevant for a particular query. So we want to chunk them. The size we're giving them is 512. This overlap basically says the difference, or there should be like a 50 unit overlap between a document and the other document, or between a chunk and the other chunk, so a 50 character overlap. So maybe this one is 500. The mark size for this is 512, and the index ends at 512. The next chunk is going to probably start from 462, if my math is correct. I don't know if it's correct, but yeah, 462 to the next 512 chunk. And that's what the overlap does, just basically so that we can chain the chunks together and keep some context between them. Then we're going to create embeddings using the model router embedding model. we're using OpenAI text embedding 3 small. This inherently has a dimension. It creates embeddings from the documents or from the chunks in here. So for each of the chunks, we pass it into this function, which uses this model to create embeddings for each chunk. And then because we're using this particular model, the dimension of the vector is inherently 1536. So the number of the length of the vector array is around this amount, 1536 numbers inside that vector. All right, so we have the embeddings for each of the chunks to create a Qdrant or instantiate our Qdrant vector so we can access it. As I said, make sure you have your Qdrant URL and your Qdrant API key in your environmental variables. We're going to use that so that we can create a new or instantiate a new vector. We create an index in our vector store called Nigerian folk stories, and then we declare dimension. So because we're using this model, we have to make this 1536. Then once that is done, we start to obsert the embeddings. So basically, if the embeddings were not defined prior, it will create it, but if it was defined, it will update it. It's just a very nice way to make sure that your vector store is up to date. Now, there's one more thing here, which is the strategy in which we're chunking the document. Here, as you can see, it's in sentences. This means that this will create an algorithm that looks for the nearest full stop or get the sentence in its context. Because the way RAG works is that it checks for similarity. It doesn't really reason per se. So we need to make sure that our sentences are coherent enough and they're stored in the vector store. So when the AI agent is trying to understand or passing a query, it has the entire context of a sentence. There are multiple other strategies you can use. There's recursive, which tries to find the smartest way possible to convert that into chunks. But from my experience and with this kind of project, it's not really the best. So there's sentence and there are a couple more. We can check them out on here. Yeah, so we have recursive, which is smart. We split it smartly based on content structure, character, token, markdown, semantic markdown, HTML, JSON, latex, sentence-aware splittings. So for our project, since we're dealing with a story, I think a sentence-aware splitting might be is good enough for what we want. Okay, next thing is we're going to create the agent that we're going to use for telling us the story. So I'm going to create a rag agent.ts file, and then I'm going to copy this. All right, so ignore this for now. So we're basically creating a tool to allow the agent query our vector store or our database. So this tool is given to the agent as a method to convert its own queries into embeddings that we will use to search this vector store, this Qdrant vector store. Right? And then we get relevant context that the agent can use to give us an answer. Right? So, but as you can see, to define it, we have to give it a vector store name, which is the name of the store we created here, Qdrant vector. And to connect them together, we have to basically add them into this index file, which we'll get into in a moment. So we have a vector store name here, and then we have the index name of the index that we created in store. And then this is the same method we're using to create embeddings and the same model. It's very important that you use the same models for the tool and for creating the embeddings on here. Because since this guy is going to create like a 1536 dimension vector, and you're trying to find the similarities between the query and the records in the database, they have to be at least the equal size, so that you can get the best relevant data. So the next thing is to define our instructions. So we'll create a file called rag agent instructions. I prefer to create my instructions on my system prompts in a different file so that I know how to orchestrate the instructions. The instructions is a very key part of building AI agents. So just make sure that to make it as clean as possible, you can even put it in like on a Word document or on Google Docs. Draft out your instructions on there, then copy it and paste it on here as well if you wanted to. So now we have our agents. Are we done? Not quite. We still need to register this agent in our Mastra singleton instance. We do not need most of these things, so I'm just going to copy our implementation from our previous project. I've basically done this before. This is just to show you how it works, step by step. Okay, we're good now. So we have registered our agent in this singleton instance. We have registered the vector, so our Mastra instance knows about all of the different vector stores that we're using in the project, right? And we've also created a storage for our agents to use. Okay. Next thing is to basically see this work, right? To do that, we are going to run pm run dev. Yeah, we haven't set our env files yet. Let me do that. So I'm gonna cursor env. Then I will paste this. I'll paste the required environmental variables on here. Then we have added our environmental variables and we're waiting for Mastra dev server to start. Okay, there we go. All right, then we're going to open up this on here to test it work. So this is the agent we defined. Okay, so we're going to tell the agent to tell us a story about why the sun and moon live in the sky. I remember this story in the book. So let's see if it's able to get it out. That's about the story of why the sun and the moon live in the sky. Wow, okay. So it's basically saying, it was able to get some information. Let's look at what it did. It asked this is the query in which it got, saying, why the sun and the moon live in the sky, Nigerian folk story. And then this went to our vector database, tried to look for contexts that are similar to this particular sentence. And it got a couple, which is basically, I think this is the first chapter or the first sentences from that book. So it's more about the relevant things, not really like a reasoning of what it did. It's trying to get the relevant context, and according to vector databases, these are all the things that are currently relevant. So from that information, it was able to give us a story that says the sun and water were great friends. I think the whole crux is that the water kept on coming into their home, and then there wasn't any space anymore, and then they had to go and live on the roof. So I think I'm just going to ask it, what do you think the moral is? It's going to put in some other information, moral of why the sun and moon live in the sky story. But the book doesn't really have anything like that has to do with the moral of why the sun and moon live in the sky. Not in the literal sense. There isn't a word that says moral of why this. It's something that you have to sort of understand. So the agents tried to pass this query into the vector tool, and it got basically nothing related to that story, right? So let's see what it was able to find out. The story why the sun and moon in the sky is considered an explanatory or just so sorry Nigerian folklore. It provides a unique explanation for why the sun and moon are found in the sky rather than on Earth. Apparently, blah blah. While the retrieved context does not explicitly state a moral, we can infer a few possible lessons from the story itself. The importance of understanding limits. The sun's generosity is inviting water and all his people from his home without fully considering the consequences led to him and the moon being displaced. Hospitality and friendship. The sun's willingness to accommodate water shows the value placed on friendship and hospitality, but also hints at the need for balance and boundaries. Actions have consequences. A story demonstrates that every action, even those meant to be kind, can have unexpected results. It's pretty. It's a pretty, inference from what it was able to understand from the story. Yeah. So you can apply the same principle to other workflows. If you have a internal document that you need to send to your staff or your entire staff, you can create an AI agent that is trained on that document, and your staff can basically ask the question. If you have documentation about something you're trying to learn, if you're trying to learn a new language, you can copy the entire documentation and put it in a vector database and hook up an AI agent that you can ask questions to in case you are lost. That is the principle of how RAG works. Thanks for watching. In this video, we talked about what RAG is. We explained the principles of how embeddings work as well, and how an entire flow will work. We also talked about why it's so important, and we used Mastra and Qdrant to create a RAG AI agent that tells us stories about Southern Nigerian folklore. If you like more content like this, please hit the subscribe button, share, like, comment on your favorite part of the video, and maybe about what you think about the story and the morals. And thank you so much for watching. Till next time, stay awesome, and I'll see you then.